had 6 wheels and you wanted to determine the probability of being able to open the lock. So we're still in the middle of our probability. So here's the next problem in the iteration. A committee of 4 people is randomly selected from 8 females and 12 males. Determine the probability of getting a committee that has all females. So just for curiosity's sake, remember that probability of an event talks about the number of acceptable outcomes. Of that event compared to the total number of possible outcomes. Probability is a ratio which expects you to be able to count. But with probability, you don't have to worry about arrangement like we do in some counting exercises. So here, we are very likely going to approach this problem by saying that we got blanks. I've got to seat 4 people to be finished. So I got fill in the blanks 4 different times. And my specific requirement is all females. But I also have to consider the total possible outcomes, whether I like what I got or not. So how many people could satisfy the first position? Any of 8 people. And how many total people did we have to select from? We have 20. We are selecting 4 people, but we're selecting from a pool that's much more than 4 people. So there are 8 things that we're okay with, but there are 12 things that we're not okay with, giving us a total of 20 different outcomes. And because you can't be both the first and the second person on the committee, now we're down to 7 out of 19. Then we're down to 6 out of 18. And then we're down to 5 out of 17. They could ask you for a fraction, but with most probability problems, they ask us for a decimal value. So if they do ask for a fraction, we know we can do the numerator-denominator division problem and convert to a Math 1 operation on the end of the exercise. But those are usually reserved for the problems that are like card problems and the problems that are dice problems, because those are easy counting mechanisms. This is a little bit more challenging counting mechanism out there. So we're going to need to multiply our values together here, and we can do it in pieces if we want. If we do it in pieces, then we have an 8 times 7 times 6 times 5 in the numerator, and we have a 20 and a 19 and an 18 and a 17 in the denominator. And then we've got that 1680 that needs to be divided by that 116,200. And we come up with a decimal value that is going to be 0.014 if they want 3 decimal places. Now they'll tell you how many decimal places to keep. Sometimes they want only 1, sometimes they want 6. 6 is usually when you've got a much smaller chance of having the probability there. This is a pretty good sized probability. It's still less than 1%, but it's okay. Now, probably they're not interested in a fraction in here, but remember, if you need a fraction reduced to lowest terms, you can build the fraction. You can go to the math function. You can pick option number 1, but I'm not thinking that that's probably going to be something that they would ask for, because that's kind of a strange looking fraction. I can't envision having 415 of something and only get to keep 6 of them. Because at my house, if there's 415 M&Ms, I'm eating 6 in a handful several times. So it just doesn't work that way. But you could get a fraction, and they could ask you for that. So either way you look at that, might be a fraction. If that were the case, then they would be looking for this, but more than likely they're going to be looking for the decimal value. At least one of your problems is going to be a problem that would be conducive to Venn diagrams.